All right, everybody. Welcome back to the drive-thru. Hope everyone had a wonderful weekend. Hungry? Stop by the deli, get yourself some carrots. That's it. It's terrible. Okay? All right, so all new stuff today. So I'll try to do this as quickly as I can without going too fast, which is the hard thing. But you might have to watch this video again. So we now are going to institute another dimension, okay? The Z dimension. You might ask yourself, why have we been learning all this math on flat surfaces since we don't live on a flat surface? And the answer is kind of convoluted. One side of it is it's kind of archaic. There's a better way to do things than the way we've done them. Okay, but the second side of that is you can't truly understand how to work in 3 dimensions if you're not really good at working in 2 dimensions, and the 2-dimensional geometry or coordinate geometry, which is what we learn, is still very applicable because all you got to do is kind of shift your dimensions and you can make it map onto any surface that you want. So if you think about a building, while a building is certainly 3-dimensional, it's just a series of segments that are connected. It has to be. Okay? Now there's some really cool buildings that are not that way, and those are the people that are very gifted at understanding working in 3 dimensions. Specifically, I think there's that molecular studies building down at UC. Have you ever seen it? It has no right angles in the entire building. The floors aren't parallel to the ceilings. It's really kind of wild. It's kind of a famous architectural accomplishment here locally. So anyway, here we go. Here's what you need to understand. There's this right-handed system, and the reason they call it right-handed system, oh, hold on a second here. Let me try this. This, that. Okay, the right-handed system indicates a way to remember that the x-axis, oh gosh, failing. The x-axis is the right hand. The y-axis is the left hand, and the z-axis is the head. Okay? So if you can imagine a stick figure with their arms forming a right angle, that's what I'm trying to, and now you might want to do that with your own arms and just figure out what I'm talking about. That's the positive ones, okay? So this is positive x, positive y, and positive z. These pink lines, or dotted lines, indicate a negative x, a negative y, and a negative z, okay? Don't freak out. It's okay. All right? Johnny, would you mind hitting that door for me? Okay, so one thing that helps us graph points in 3 dimensions is if we use rectangular solids. That helps our audience visualize where this point is. So we're going to start out by graphing the point 3, 5, 10. Notice these are all positive. So start out with your typical XY plane, but don't write any letters on it. And then go here to the origin and diagonally draw one coming towards you. Then, to help people visualize that this is 3 dimensions, dot your negatives, even though this problem involves no negatives. Okay? Now, when we graph this point, remember, you might want to write your letters so you don't get them confused. How many spaces are we coming out in the x direction? 3. When you write your lines on the x-axis, your little dash marks, they should be parallel to this y plane. So 1, 2, 3. Okay? How far are we going on the right? Those tick marks should be parallel to this plane. So 1, 2, 3, 4, 5. And we're going up 10. Those are easy. They're just still horizontal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So this is actually what we're doing. Now I'm going to trace our steps in pink, and then we'll draw a rectangular solid to help us. We've traveled 3 units in that direction first. Okay? Then we are going, watch how they got to be parallel. 5 units in that direction. And then we are going 10 units in that direction. Okay? The final thing I want you to do is turn this into a rectangular prism. So if you remember how we did that, we would always start with the front face and then take a line like this and make it parallel. So let's see, let me think. Where would that hit? This should hit here, which isn't exactly parallel. Okay? And then draw this up here, here, and now you've kind of got a box to help visualize the situation. Next time it might be easiest to draw the box first and the point second. You just have to have an idea of how to do this. It's something new. Don't worry about your test. I just want you to understand what you're doing for today, okay? So far, so good? Okay, told you, all new things today. You might have to watch this video twice. All right, so now there is a 3D distance formula. You should really recognize it. It's very similar, amazingly, to the 2D. It's x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So, not hard to memorize at all because it's so similar to our other distance formula. If you remember this problem, what's the distance from that point to that point? The diagonal of a box. Do you remember this? If you happen to remember that, if we call this x and this y and this z, here's how we did this problem. We turned that pink line into a hypotenuse. So in order to do that, I had to create a red line. Now, what is the length of that red line from the Pythagorean theorem? Somebody? What is the length of that line? Not radical 2 because it's not a square, but close. Yes, the square root of x squared plus y squared. If that was x squared plus x squared, it would be radical 2 times x. Good. Okay, you remember that? So now you've got a right triangle that looks like this. Oh shoot, that should have been red. Okay, it looks like this. Do you agree that it's a right triangle? Here's my right angle right there. And so I've got z here, and I've got square root of x squared plus y squared here. So if I wanted to figure out what the hypotenuse was, I would do z squared plus square root of x squared plus y squared squared equals h squared, right? So then what would h equal? The square root of z squared plus x squared plus y squared, because this thing would cancel with that. Okay? We've already done that in a different video, but this right here is how they get that. And I hope that maybe half of you understand that. Okay? All right. So we'll just do an example. This is really simple. You don't even have to Widmaploy for this. D is the square root of, I'll just try to keep it as positive as I can, but it doesn't matter because we're squaring it. 3 minus 2 squared plus negative 4 minus 10 squared plus 6 minus a negative 1 is 6 plus 1 squared. So it's the square root of 1 plus 14 squared. Is that 196? Plus 49. So 50 plus 196 is 246. Uh-oh. Okay, 4 doesn't go into that, so 16 doesn't go into it. 9 doesn't go into it. 25 doesn't go into it. 64 doesn't go into it because 4 doesn't go into it. Could that possibly be simplified? I think it is. What's 246 divided by 2? That's all we got to do. 132. Also, that is divisible by 4. I'm such a liar. Sorry, it's 123? All right, I think that's the answer, wildly enough. Okay? Got it? All right. Here's something else that's totally new and totally unrelated to what we just learned. Okay, this kind of the point of this is just stretching you and making you learn things that might be a little out of the ordinary. Okay? I don't know how else to explain it. It's about putt-putt, but it's really about reflections and angles and congruent triangles. Okay? What if I wanted to take this ball at the red marker and putt it into the blue hole? Who's got a strategy for that? Sam? I would want to... Okay, I hit it to a point where it's equidistant. That's kind of the concept. Minimally, I'm going to have to bank it off at least one side, right? Okay, now, you'll find out as we do more problems. There's more than one correct way to make this shot. But if I wanted to do it the easiest possible way, what I do is I take this blue line, and since I cannot shoot directly between the red line and the blue line, I try to reflect the blue line over a wall that I could shoot directly at. Okay? So, I know how to do this, so I'm just going to do it the quick way this time. You guys are going to have to use some problem solving. Does that look like it's about a perfect reflection-ish? Got it? So if I call this A and this B, I would call this B prime, okay? Now here's the cool thing about geometry. If this is a right angle and these are congruent, then we've made a reflection. Do you agree? Well, now all I have to do is see, hold on one second, am I capable of hitting from this red line? Yes, I can. So that means that's where I should aim, at this point right here. And if I was to hit that point and it was a completely flat putt-putt surface, that's exactly what the ball would do, due to the fact that triangle 1 and triangle 2 are what? They're congruent. That's how that works. Can you see the geometry behind that? Okay. So, the last thing we'll do in the video is one that's a little harder. See, I have more walls, so more barriers. So you have to think backwards, okay? What is the last wall that your golf ball will need to bank off of? We'll call this right, top, left, bottom. It's going to bank off the bottom one last, right? So that is the first reflection that you should do. So, let me get my lines right. We'll go here. We'll do this in pink dotted lines. Okay, so I'm going to reflect. Does that look okay? And I'll bounce back and forth here. If I call it again, this A, and this is B. Now this is B prime, okay? What is the second to last wall that I will bank the golf ball off of? The left wall. So now I need to reflect B prime over the left wall. What do you think? Up? Up? Let's see. I can't see that low. Yeah, you're right. You're right. Okay. So like here-ish. Is that okay? What am I going to call that? That's right. B double prime. Okay? Okay, now I cannot probably hit this wall, the left wall as we're referring it to, without first hitting what? The top wall. So now I have to reflect B double prime. And what I'll do, let's see, let me extend this. I'm just going to extend that wall to give me a better opportunity to reflect it properly. Take this. Okay, tell me. Is that good? Once again, just to be clear, I'm trying to make it so that this segment is equal to that segment and that that is a perpendicular. Okay? That's how you reflect things. What am I going to title this point right here? That's right. B triple prime. That indicates we've done 3 reflections. Now, if I find out that I cannot, so I got to kind of like, what I'll do here is I'll use a green, and if I can't do it, then we got to go again. So can I get directly to there? I cannot. So what would I have to do before I got to the top wall? I'd have to hit the right wall. Okay? So, what am I going to do? That's right. I'm going to reflect B triple prime over that wall. Okay? So now I take this. What do you think? Too far? That better? Okay. B4 prime. And now I'm telling myself that to be the golf putt-putt champion of the world, what I need to do is aim right here. Now let's go ahead and trace out the geometry. This is pretty cool stuff or I wouldn't teach it. Okay? What's going to happen once it hits the right wall? It's going to bounce right towards B triple prime. And then what's going to happen when it hits the top wall? It's going to bounce right towards B double prime. And then what happens when it hits the left wall? It's going to bounce right towards B prime. And then from here, it's an O. I feel a putt-putting field trip coming on. I mean, come on. I shouldn't just teach you guys things. We should experience real-life experiences. That's not a bad idea. Your test is based on your putt-putt finish. I like it. I like it. All right, hey, I'm going to link this to another video. You're going to want to check that video out. Can I get an excited boom?